I'm actually adopting a different approach to teach this topic, arithmetic series. Here is a different perspective of the same. So what we will do is we'll try to understand the derived formula so that it can be utilized and problems can be solved using the formula. So question number 1 says sum of first n terms of an arithmetic sequence with first term and nth term is given by S of n equals to n times t1 plus tn divided by 2. Show that it works for all arithmetic sequences. So that's the type of question I have here. So we know that sum of first n terms of arithmetic sequence is given by this formula. Now the idea here is to understand the formula. So what is this? First thing is we should understand what arithmetic series is. So we had been talking about a sequence. Sequence is the terms written one after the other and they follow a pattern. So a general formula can be written for them. But when we add these terms and we are interested in some of these terms, then we call that process as a series. So when we say arithmetic series, then we are adding terms of an arithmetic sequence. Okay, so that's how they are related. So it is basically arithmetic sequence whose sum we are interested in, sum of n terms. That is what we are interested in. Let's see how it goes. So we'll take very simple examples so that we get the concept. Let us say that we want to add these terms. That means 1 plus 2 plus 3 plus 4 plus 5 plus 6. So these are 6 terms. 1, 2, 3, 4, 5, 6. So they form arithmetic sequence, right? Starting with first term as 1 and sixth term as 6. Correct? Then as per the formula, we can say number of terms are n, which is 1, 2, 3, 4, 5, 6. Correct? So we say n equals to 6. Now what is t1, term number 1? t1 is 1. What is tn? Since n is 6, right? So we can write this as t6, right? Term number 6. 1, term number 1, term number 2, term number 3, 4, 5, 6. Term number 6 in this case is also 6, right? If we plug in all these numbers here, we get the sum of first 6 terms, right? 6 terms, which is equal to 6 times 1 plus 6 divided by 2. Is that okay? And this is equal to 6 times 7 divided by 2. 6 times 2 is 3. 3 times 7, 21. Correct. That is what you get from the formula. Now, let us try to understand how we came to this formula. So let's do like this. We've got 6 terms. Let's group them together. So if I group 2 terms into one, let's say we take first and the last term and we group it. And what are we doing? We are trying to add them. When you add 1 and 6, what do you get? We get 7, right? Now let's take these two numbers, second and second last, and add them. When we add them, what do we get? We get 7, right? Now let's take these terms. Now when we add them, what do we get? We get 7. So what do we see here? We get total as 3 times 7. So 7 is this term, sum of first and last. Do you understand? Sum of first and last. So sum of first and last was 7. That is the number here, 7. Do you see that? 6. 1 plus 6 is 7. And n over 2 is number of pairs. So if we have 6 terms, then number of pairs should be 3. Half of 6. N by 2. Half of 6, right? That's how you get this, right? Now you will think that this was such a simple problem. I just took 1 to 6 and showed it. if I take some other set of numbers, let us say that we start with some other number, right? Let's not start with just 1. Let's say we start with, let's say, a number 3, right? And let us not go up by 1. Let's go up by, let's say, 2 this time, okay? So we have terms like 3, 5, 7, 9, 11, 1, 2, 3, 4, 5. Okay, let's take odd number of terms and see what happens, because you can't pair them all, right? That's kind of difficult. So let's see what happens here in this case. Start pairing. Now what do? We pair first and last term. If I do first and last term, how much does this add to? 3 plus 11 is 14. Okay. Now how about these two? 5 plus 9 is also 14. We are left with one term. So whenever there are odd number of terms, we will always be left with one term, correct? Because even numbers will pair up and the term in the center will be left out. But see one thing. Do you notice one thing? It's already half of 14. 7, right? 7. Half of 14. So what is the total of this? If I want to add this up, what should I get? If I add this up, so I get 14, 14 and 7. That means 2 and a half 14. Do you see? This is half of 14. 2 and a half of 14, right? If I use the formula, then what do I get? Let's see. So sum of terms, how many terms I have? 1, 2, 3, 4, 5 this time. So we got 5 terms. Sum of 5 terms, right? N is 5. Divide by 2. Let me write this 2 under n. And then add first and last. That is T1 and T5 because we got 5 terms, right? First is 3 and then 11. Do you see that? And this is equal to what we expected. 3 and plus 11 is 14, right? So we get 2.5 times 14. Do you get this sum? And we get our answer, right? So that is how we are going to get, you have seen, that is how formula works, and that is how we can find sum of different number of terms in our calculations. Correct? So 28 plus 7, 35. So that is how you get your sum. Now let's take a very, very general formula just to show that it always works, right? In this case, let's start with term. Instead of 1, 2 or 3, let's start with a general term. And let us say that my general term is A. In arithmetic sequence, every next term will be plus common difference. And let's say common difference is D. Then the next term will be A plus D. Okay. If I add one more D, I come to this is my first term. Let me write my term numbers. Let's say this is my term number 1. This is my term number 2. Here I'll write term number 3, 4, 5, and let's say 6. So we are taking even number of terms. So they will be divided into 6 terms. So n is 6 and divided by 2 will be 3. So next term should be plus D, right? So it will be A plus 2D. Another D, A plus 3D. This will be A plus 4D, and that will be A plus 5D. A could be anything. A could be negative 10, whatever. D could also be a negative number, right? The sequence could be decreasing, any number. So this is a very, very general formula. Now here we will add the first term with the last term. So what do you get when you add these two terms? A plus A, 2A. 2A plus 5D, correct? So that is what you get. So 2A plus 5D, what you get. So let me write A plus D, okay? Which is 2A plus 5D. Is that okay? Now let's add these two. What do we get? A plus A, 2A, plus D plus 4D is 5D. Do you see? Same thing we got, right? And if we add these two, A plus A, 2A, plus 3 plus 2D, 5D, 3D plus 2D, 5D. So we get 2A plus 5D. So we got the same thing inside, right? And how many of these pairs? 3. 3 is 6 divided by 2. So 3 is 6. 6 divided by 2. First term plus last term. And let's see how it works with our formula. So we are doing this S of n. We got 6 terms. We'll write S of 6 equals to, n is 6 for us, 6 over 2. And what is T1? T1 is term A, right? A plus, what is Tn? Tn is T6, which is A plus 5D. Is that okay? So this is equals to 3 times 6 divided by 2. 2A plus 5D. Do you see that? 3 times 2A plus 5D. Do you see how the formula relates in general with every arithmetic sequence? This is an arithmetic sequence, right? And when we add these terms together, it becomes arithmetic series. So what I'm trying to say is, if I write comma here, we are talking about a sequence. And now if I say I'm interested in sum of first 6 terms of this arithmetic sequence, then we all of a sudden come to a topic, arithmetic series. Okay, that is how we are connecting sequence with series. And I hope you understand the sum of first 10 terms of arithmetic sequence can be written as first term plus second term times half of the pairs. Do you see that? N over 2 is half of the number of terms which forms pairs, number of pairs which you can get from a sequence, correct? That is how you may understand this, and it may be an additional help to solve problems on arithmetic series, correct? I hope that helps you. Thank you.